In 1984, a construction crew struck something in the mud, a human skull, then another, then dozens more. Beneath that pond lay 168 bodies with 91 intact human brains still inside them, some over 7,500 years old. Scientists would extract DNA from tissue older than the pyramids by 2,000 years, and what it revealed is still hard to explain. None of it was ever supposed to be found. Steve Vanderjack was running a backhoe through the sticky peat, expecting nothing more than another day of moving earth. The bucket clanged against something solid. He climbed down, brushed away the mud, and found a human skull staring back at him from the dark, waterlogged ground. The work site fell silent. Within hours, local authorities cordoned off the area. Word spread quickly. This was no ordinary find. More skulls surfaced as the peat was peeled away. First a handful, then dozens. Vanderjack, shaken but resolute, insisted the machine stop. The construction crew called in the Florida Division of Historical Resources, and the site was secured under watch. By the next morning, a team of archaeologists and forensic specialists arrived. They found the skulls lying in dense clusters, buried just beneath the pond's surface. The bones were so well preserved that even the smallest details, a child's tooth, the curve of a jaw, remained untouched by time. The peat's heavy, tar-like grip had protected them for thousands of years. The team realized they were standing atop a cemetery older than any recorded settlement in the region. Vanderjack's decision to halt the excavation set off a chain of events that would draw scientists from across the country. The pond, once destined for drainage and development, became a window into a forgotten world. The urgency was clear. Every hour exposed more remains to the air, risking the loss of fragile tissue and ancient secrets. The discovery demanded immediate action, and the scientific investigation began. Glenn Doran, an archaeologist from Florida State University, arrived at the Windover site with a clear question: just how old was this bog cemetery? To answer it, his team collected samples of bone collagen and charcoal from the burial layers and sent them to radiocarbon labs. The results left little doubt. The earliest graves dated to around 7,300 years before present, and the latest to about 5,900. That means the pond served as a burial ground for roughly 1,300 years, a time span that covers more than 50 generations. No other cemetery in the eastern United States shows this kind of long, unbroken use. The radiocarbon dates, measured in calibrated years, placed Windover's origin deep in the early Archaic period. This was a time long before the rise of cities or the construction of monumental tombs anywhere in North America. For context, the oldest pyramids in Egypt would not appear for another 2.5 millennia. Each burial at Windover was anchored in this ancient era, making the site a time capsule that spanned centuries of change and memory. Doran's team mapped the burials with painstaking detail, recording their depth, orientation, and association with artifacts. The radiocarbon evidence revealed not a single mass burial or catastrophic event, but a continuous tradition. Families returned to the pond again and again, laying their dead in the same peat, generation after generation. The sheer longevity of this practice points to a community with deep roots and enduring ties to a single sacred place. Drainage of the Windover Pond presented a technical hurdle that called for both speed and precision. The team installed a network of 150 well points around the perimeter, each sunk deep into the peat and connected to a high-capacity dewatering system. Together, these pumps could move up to 700 gallons of groundwater per minute, enough to steadily lower the water table and expose the pond's muddy floor without disturbing the fragile remains below. As the water receded, the dark, spongy peat revealed the full extent of the cemetery. Bodies lay in tight clusters, each skeleton articulated and undisturbed, some with knees drawn to the chest, others stretched flat, all oriented with careful intent. The team mapped every burial in situ, recording orientation, depth, and the exact position of grave goods. This meticulous approach allowed archaeologists to capture the original layout of the cemetery, preserving vital clues about burial customs and social structure. The field crew worked in shifts, constantly monitoring groundwater levels and reinforcing the pond's edge to prevent collapse. Every step required coordination, archaeologists, engineers, and laborers moving in concert to balance excavation needs with the preservation of ancient evidence. The success of this effort meant that 168 individuals could be documented and recovered with their context intact, providing a rare, undisturbed window into archaic period mortuary practice. The ingenuity displayed during this phase set the stage for the scientific breakthroughs that would follow, as the team prepared to confront the mysteries of preservation that made Windover unlike any other site in North America. Inside the Windover pond, peat did what time and climate usually cannot. The chemistry of this ancient wetland created a sanctuary for the human body, preserving not just bone, but the most delicate tissue of all, the brain. 91 skulls still cradled shrunken, grayish masses, each brain reduced to a quarter of its original size, but still showing the folds and grooves of living tissue. This level of preservation is almost unheard of outside frozen tundra. The secret lay in the pond's near-neutral pH, buffered by limestone beneath the peat. Unlike the acidic bogs of northern Europe, where brain matter dissolves within years, Windover's peat maintained a gentle balance, neither too acidic nor too alkaline. The waterlogged soil was starved of oxygen, with a redox potential between -200 and -300 millivolts, conditions so reducing that bacteria and enzymes, the usual agents of decay, were nearly powerless. Humic acids and plant-derived phenolics wrap the remains in a natural shield, slowing the breakdown of proteins and fats. The result was a kind of chemical stasis, locking in microscopic details for more than 7 millennia. This rare combination of factors didn't just keep the brains intact, it protected the very molecules that would later allow scientists to extract ancient DNA, opening a window into the lives and ancestry of a people long thought lost to history. Inside a sterile lab, a walnut-sized sample from Windover's ancient brain tissue yielded a breakthrough. Using short fragment PCR, Bill Houseworth's team amplified a 120 base pair segment of the HLA gene. The result? Mitochondrial haplogroups A2, B2, and X2A, lineages still found in Native American populations. Next-generation sequencing confirmed these patterns, placing Windover's people within the early Native American genetic cluster, though not matching any single modern tribe. Isotope analysis of tooth enamel showed hydrogen values from -55 to -62 per mil, consistent with Central Florida rainfall. These children drank local water, pointing to a community rooted in place, even as distant trade goods appeared in their graves. Among the 168 burials, a 15-year-old with severe spina bifida stands out. Despite paralysis, his bones show years of healing and care. He was buried with grave goods and wrapped in a 7,200-year-old twined sedge textile, the oldest woven fabric in the Americas. Genetic links to nearby individuals reveal a close-knit clan, returning to this pond for generations, bound by kinship, skilled craft, and enduring compassion. Grave 102 stands apart from the rest. Excavators uncovered the remains of a man, about 30 years old, whose bones told a story of violence. A clean, sharp cut sliced through the third and fourth cervical vertebrae, a mark left by a stone tool, likely in a single, deliberate motion. His left upper arm showed a fresh, V-shaped fracture, the kind made by a heavy blow at the moment of death. There was no sign of healing on either wound. Forensic analysis ruled out scavenging or accidental damage. These injuries happened as he died, not centuries later. Some researchers see evidence of ritual execution, perhaps a punishment or a ceremony meant to separate body and spirit. Others point to the lack of grave goods and the prone position as hints of social exclusion or conflict. Whatever the motive, this act unfolded more than 2,500 years before the first stones of the Egyptian pyramids were laid. In a world often imagined as peaceful and simple, Windover's oldest homicide forces are reckoning with the full spectrum of human behavior, compassion and brutality, care and control, already present on the North American continent millennia before written history began. Today, Windover's DNA and burial evidence overthrow outdated myths about early Americans. These ancient people nursed their injured, wove complex textiles, and carried genetic legacies that still shape populations. Each new discovery urges us to reconsider who we are and how much of our shared past remains hidden in the ground.